Okay, so in this one we're going to be looking at how many grams of silver chromate we will need to precipitate when we have 150 ml of silver nitrate with a concentration of 0.5 mole and are added to 100 ml of 0.4 mole potassium chromate. So firstly, let's just write out our balanced equation before we do anything. So our silver nitrate plus our potassium chromate creates our silver chromate and our potassium nitrate. Alright, so let's just make sure that this reaction is balanced, that our chemical reaction is balanced. So if we look, we can see that we've got, sorry, I've forgotten the 2 there. We've got too much potassium on the left-hand side compared to the right, so we need to have more potassium on the right-hand side. And to then balance this side of the equation, we then need to put a 2 in front of the silver nitrate, and now our reaction is balanced. Okay, so let's work out what we do and don't know. So again, we're going to be using the same 2 equations that we've been using, which is our C over NV and our N M over N. So what do we know? Now we want to look at our silver, we want to work out silver chromate. Now we can look at what we know about the reactants in this. So if we have a look at our silver nitrate, we can have a look at the left-hand side of the equation. So for our silver nitrate, we know our volume. Sorry about that. We know our volume, which is 0.15 litres. And we know our volume, our concentration, which is 0.5 moles. Now for our potassium chromate, we know our volume, which is 0.1 litres, and we know our concentration, which is 0.4 mole. We don't know N for either of these. Now that's going to require for us to look at, firstly we need to work out which is the reaction limiting reactant in this equation. So let's work out firstly how much mass, which is how many grams we need for each of those. Now when we're looking at our limiting reactant and our excess reactant, the limiting reactant is the one that is completely consumed, whereas the excess reactant will be the one that is not completely consumed. So when we are working out how many grams we have left over, we can then work, the one that has the smallest number is the limiting reactant. So if we work out how many moles of our silver nitrate and our potassium chromate, so that is C N over V, we then rearrange that. Okay, so then we need to rearrange this equation. So we know that 0.5 mole equals N over V. So if we move up, and we know what our volume is, which is 0.15. Move that to the other side so that we have N equals 0.5 times 0.15, so N equals 0.075 moles. So we do the same for our potassium chromate. So that is 0.4 equals N over 0.1. So 0.4 times 0.1 equals 0.04. So our limiting reactant is the smaller of the two. So our potassium chromate is the limiting reactant in this case. So now that we know which is the limiting reactant, we can use our mole ratio to work out the ratio of reactant to product. Okay? So we have our mole ratio, we have our unknown on the top, which is our silver chromate, N, and on the bottom we have our known, which is our reactant limiting factor, which is our potassium chromate. Now, in our balanced equation, we can see that the ratio is 1 to 1. It takes one amount of this to create one amount of this. So our ratio is 1 to 1. Now, we know N of our potassium chromate. So our reaction then comes, or equation, sorry, then comes Ag2, so our silver chromate over 0.04 equals 1 over 1. So then if we rearrange our reaction by moving this over here, so that it then becomes 0.04. So our number of moles of our silver chromate is 0.04 because it's the same. The ratio is a 1 to 1 ratio. So we still need to work out our grams, which we need to use this ratio, this equation here. But we now have everything, but we now know what our N is. We know what our M, so we know how many moles of our silver chromate we have. We know what the mass is now. Sorry, the mass is what we want to find out, which is this one here. And we can work out what our molar mass is. So if we have N equals M over molar mass, we know the N, we know the molar mass. So our equation becomes 0.04 equals our mass, which is our unknown, over the molar mass of silver chromate. Now you can use that by working out the atomic weights off the periodic table, which is, if we work it out, it's 2 times 107.9 plus 1 times 52 plus 4 times 16, which is our silver, our chrome, and our oxygen, which then in total equals 331.8. So our equation then becomes 0.04 equals M over 331.8. We move this over here so that it's then 0.04 times 331.8 equals our mass. And our mass, in how many grams of silver chromate we need, is 12.4 grams. So that's how you work it out if you don't have the moles of either of the reactants in your equation.